Hello. In this example, we're going to take a look at how Flowmaster V7 can help you analyze your pressure relief systems. When dealing with gas systems, it is critical to incorporate pressure relief systems to ensure safe operation and to prevent possible system failure or significant downtime. With Flowmaster V7, you can analyze the pressure-flow relationship in the system, accounting for full compressibility of the gas in either steady state or transient. You can utilize the integrated flow balancing module to size components, such as orifices, to produce a specified mass flow rate, while also understanding limitations, such as choked flow. In this example, we're going to be looking at a reactor with ethane gas that's been charged to a certain pressure, 2500 bar, and a bulk average temperature of 200 degrees Celsius. Now with this example, we know that sometimes we could have runaway reactions and hotspots forming. As a result, what we would want to do is drop the pressure as quickly as possible to about 1500 bar to stop the reaction and thus letting the system cool back down. The first stage of what we're going to look at is sizing the system and the vent lines, which you see on the top here. Now, making sure that we have the proper size for these vent lines will allow us to ensure that we can expel the proper amount of gas. Oftentimes, when dealing with compressible flow, where we're going to have fairly high Mach numbers, fairly close to 1, we do need to be concerned with the flow that we have and to make sure that the system does not become choked. So for this example, we're going to be looking at 3 different sizes, and we're going to run a parametric study, and we're going to do it with a 1/2 inch, a 1 inch, and 2 inch vent lines. And so we can quickly run those 3 analyses and see what type of flow rates we have coming out of our vent systems. And so if we plot all 3 of them against each other for mass flow rate, as we would expect, we see a much higher flow rate for the 2 inch versus the 1 inch and 1/2 inch. But we can see it's actually quite a significant difference due to the compressible effects of the gas. We can also look and identify what the Mach number is so we can understand if we are fairly close to choking, which for 2 of them we are, but for the 3rd one we have fairly good numbers. And we can see how those directly relate to the velocity in the system. Once we have that, we are also going to want to look at the transient behaviors of the system. So if we go ahead and we pick, let's say, the 3 different sizes, again 1/2 inch, 1 inch, and 2 inch, and we can run a transient analysis for each of them, and we're going to run for about 20 seconds. And again, what we were looking to do is bring the pressure down to 1500 bar inside of the reactor, where we know that the reaction will be stopped. If we look at the 1/2 inch example, we can see that even after 20 seconds, it barely gets down to just above 2000 bars. So probably not the design that we're going to want to go with. So let's take a look at the 1 and 2 inch pressure relief systems. From the steady state results, we would expect that these would decrease in pressure much quicker than the 1/2 inch line. One of the interesting results we see here is that due to the compressible effects of the gas, it's not a straight linear pressure decrease as shown with the 1/2 inch line. And so with Flowmaster V7, you're able to account for this and predict the true time that it would take to depressure the system. If you have any questions or would like any additional information on how you can start solving your fluid system challenges with Flowmaster V7, please contact your local sales office.